Hi everybody, today we will be working with BEViewer Bulk Extractor 1.3, the GUI version. And first I'll begin by opening it up. So here I have it open on my desktop. It's a Windows PC. So just to get started, you have the left panel, it's the reports. And in the center you have your feature filters. You can always play with the sizing of these panels. And then you have your navigation, which will actually navigate the disk image or drive that you're trying to analyze. So we'll get started right away and begin by analyzing a disk image. And the image that we will be examining is the ouchusb.dd file. And as you can see, as I navigate to the desktop where I have the file, you can't particularly see the DD image or any other files because the file type is set to image files. So I'm going to change this to all files since I know that DD is a raw disk format and it can be handled by bulk extractor. And I'm going to open the ouchusb.dd. For the output feature directory, it is essentially where you want to place the reports that bulk extractor will generate. And in order to properly do this, I'm going to first set the directory which will contain the output directory. So in this case, you would want to set your documents, or if you have a specific drive where you like to keep your forensic information, you can set it there. I just prefer, for the sake of this tutorial, to use my desktop. And you can either type it in to the field here, click open, or you could just type it manually into the program, I believe. And for new directory name, so this is going to create a subdirectory in the folder you list up here. So in my desktop, it's going to make the subdirectory, and I will call it ouch USB because that's the name of the disk image that I will be analyzing. And finally, I'll hit select. There are some general options, tuning parameters, scanner controls, parallelizing, debugging options as well. I'm not going to touch those except for these options and the tuning parameters, which I'll get to in a second. But first I wanted to talk about the main aspects of the tool, which are these scanners. So in a small image like this, it's a USB drive that was just generated for a cyber forensics challenge, so there won't be much information other than what we were intended to find. However, if you analyze the live image of a acquired drive, you would most likely find data for all of the scanners. The scanners are pretty self-explanatory. You would want to keep the default check scanners, so you have accounts, AES keys, email addresses, EXIF data, GPS, and etc., PDFs, Win prefetch cache. You also have zip archives. So before I mentioned I was going to tweak some of the tuning parameters. The only reason I'm going to do this is because the machine I'm using for analysis actually has the number of threads, number of cores. I actually have 8 cores, so I'm going to set this to 8. Although the disk image we're working with is around 60 megs and pretty much minuscule, it's really not going to matter. One core could do it pretty fast. One core by itself, meaning it wasn't already being used by your system. The only other option worth mentioning is if the block size for your image is different, you should know this from a different analysis. When you're doing a hard disk analysis, if you see that your image has a different block size, maybe 256, 512, or 1024, I don't know, it could be various block sizes. If that's true, in this case, you would check it and then have bulk extractor use a different block size. However, in this case, I know it's a 512 block size as it's a FAT file system, and therefore I will just leave it at the default. And finally, at this point, I have no other options to implement, so I'm just going to go ahead and start bulk extractor. And as you can see, its progress is 0.0%, although all data is read, and it's waiting for my threads to finish up. And at this point, all my threads are done, and the bulk extractor has completed running, and the report is opened and ready for viewing. Let's go ahead. Now we'll go over to our reports panel, click Out USB. As you can see, I have a couple of TXT files. Now you'll realize that all the scanners did not give an output, and you might be wondering why. And the reason you might think is actually the reason. There was nothing found for the respective scanner. So we saw, if we go back to our scanners here, we have accounts, AES, emails. So in that case, those were just not found, and that's why they weren't shown. So from what we do have, we have domain histograms, which essentially just shows the frequencies of the domains that were visited. The domain.txt will actually show the individual domains and where they are. So if I actually click a feature file column, it'll actually show the location in the image on the drive where the specific string was referenced. In this case, it's the localhost file. There's some EXIF data, and it looks like it's from a Motorola Droid, and you can make your analyses from there. This is just an example of what the bulk extractor output will look like. Now, just really quickly, if we wanted to go and actually see the output folder, some people prefer to do that. Just to bring it up, the out USB. So the folder would be here, and actually you can see that there were files generated for the other filters, and I mean, the reason is they're just blank files because there's nothing there, and that's why bulk extractor ignores them. And this report.xml file is actually what bulk extractor reads from. So that is BEViewer on the GUI tool. The only difference with the command line is that you're executing the command that essentially bulk extractor is doing here. And as you can see, the scanner was terminated. I was actually attempting to show you the commands as they were running, and bulk extractor scanner terminated because I actually used the same. As you can see, if we go back here, it's giving me an error because I used the same feature directory out USB, which was already there, and bulk extractor failed. But as you can see, the commands that were referenced in the slides are being used. Bulk extractor O, and here's the output directory, and then the J is only because I'm using the options of adding 8 threads. It's irrelevant, you can ignore that. So it's essentially the syntax bulk extractor flag O, the location of the output, and then that is followed by the location of the drive. So it's the same thing, and as for viewing the files, you would just have to navigate to the output directory, which you could easily do using change directory, and then after that you would just have to list all the files and then cat the one that you would like to open. So ideally you are doing the same process, except one includes using the GUI and the other one is the command line. That's all. Video created for Sci4. Thank you.